kumquat. All right, we had done part A already, and I think we had already done part B. So let's write up the major players for part B, because we're going to need these numbers for the rest of the problem. So N, remember, is the number of data pairs. We have 1, 2, 3, 4, 5, 6. Sigma xy is the corresponding product. Keeping in mind, since x is the number of years since 2006, and this is really 0 here, this is really 1, 2, 3, 4, 5. So sigma xy, I think we got 1,344,177. Sigma x is the sum of all the x's. We get 15. Sigma y is the sum of all the y's. 404,687. Sigma of x squared is 55. And sigma of x quantity squared is 225. So when we found the slope, we got 18,997.69. And again, anytime you interpret a slope, it's always y per x. So the amount of megawatt, I can do it. Amount of megawatt hours generated is increasing by 18,000, whatever I said, 1,000 megawatt hours per year from 2006 to 2011. So that's where we left things. But I know we all need closure. And we also need 4 more parts. So part C. Find the y-intercept of the regression line and interpret. Do you like formulas? Sure, we all do. There's a formula for the y-intercept. Remember, the y-intercept for a line can be labeled as b. So what we're building is we're building that line that looks like y equals mx plus b. We just found the m to be that 18,000 number, and now we're going to find the b. The formula for b is the sum of the y's minus m times the sum of the x's over n. This one, in comparison, not as bad as our m. But notice the formula for b relies upon m. So what happens if your m is bad? There goes your b. You don't want to have a bad bm. Didn't. You're welcome. Ask your parents if you don't understand that joke. Really? No one? All right, that's fine. Actually, you probably should ask your grandparents. All right, here we go. B is equal to the sum of the y's. The sum of the y's is that 404,687 number. Minus m. Here's the deal. Unfortunately, we rounded m. M actually turns out to be an irrational. No, it's actually rational. It's just a horrible, horrible number. That decimal goes on a very long time. So because we are rounding the m here, our b is not going to be exact. So we wanted 2 decimal places, 18,997.69. Times the sum of the x's. What was the sum of the x's? 15. Divided by n. What's our n here? 6. If you're going to do this in one fell swoop, finish that sentence. You need parentheses. Very good. Just like before, let's go to 2 decimal places. I got 19,953.61. Is that okay? All right. Now we're about to see the bad thing. Here's the bad thing. At best, these are all approximations. And in fact, this is not a great approximation because a y-intercept occurs when x equals 0. When x equals 0, what year are we in? 2006. So your interpretation is, in 2006, approximately 19,953.61. So in 2006, approximately 19,973.61 thousand megawatt hours were produced or generated. What's bad about that? We're off by 7,000 megawatt hours. We know the actual value is 26,000, but we got an approximation of 19,000. That's not good. So unfortunately, the way the layout of the data is, a line may not be the best. Maybe a different type of function would work better, like a parabola or a cubic or something like that. So that's why we slip in the word approximately, meaning, hey, we know there's an error. In fact, there is a value that will tell us how good of an approximation or how good of a fit it's going to be, which is part, I think it goes up to part W. We'll find out soon. So questions on the interpretation of the y-intercept? Okay. So part D is putting stuff together. What is the equation of the regression line? Well, again, the generic equation is y equals mx plus b. The m we found last class, that's that 18,000 number. The b we just found, that's that 19,000 number. Oh, yeah, we're good. I had a minor freak out there. All right, so that's D. So remember, X represents the number of years since 2006. Y represents the 1,000 megawatt hours produced. So E, during what year? Stop right there. What variable are we solving for, X or Y? Close. Close again. Careful. So X. During what year? So find X when Y is 200,000. Please be careful and match up the units. So since this is in 1,000 megawatt hours and this is in 1,000 megawatt hours, then your Y is directly 200,000. If I was playing the jerk and I said 200,000 million megawatt hours, then your Y is not 200,000 anymore because I changed the units on you. So please be careful with that. So in the equation from part D, instead of the Y, we're going to put 200,000. And we're going to solve for X. Mike, yeah, you said on the first day we're not going to do any algebra. I say a lot of things. Okay, here's $5. All right, that's cool. No. By saying during what year, that means find X. Is that okay? How are you going to solve for X? Subtract the 19,000 number, and then what? Divide by the 18,000 number. Good. If you would, please do so. Do not round this number. I got X to be approximately 9.48. So does that mean in the year 9.5, 200,000 megawatt hours were produced? No. They didn't have electricity back then. What year are we talking about? During what year? After 2006. So what's 9 years after 2006? 2015. The during takes care of the decimal. If we wanted to figure out the month, the day, the minute, the second, we hit exactly 200,000, that's where the decimal would come in. What I don't want to happen is, for instance, if this X was equal to 9.7, and then you rounded that to 10, if you do that, then you're in the next year. Nope. You pass it up by 6 months. So the during takes care of the decimal. You're really only focused on the whole part. So even if this were 9.9999, it's still during 2015. So don't round.